And what happens next is an interpolation of the solution, which is the correction I should have on the final grid solution back to the final grid. So that's what we are doing here. We interpolate the solution and we add the correction to the previous solution U0. So let's see what the addition is. Previously, my U0 is an array like that, and the DUF is an array like that. So adding them together, my U1 is going to be basically this plus this. So this array has the smoother features, and this array has the less smooth features of the solution. So adding them together, I have the U1, and after a few post-smoothing iterations, my U1 is going to be even more improved, right? So it basically, what this post-smoothing iteration do is it removes the error that comes from interpolating the DU from the coarser grid to the fine grid. The interpolation is going to make an error, right? Okay, so if we continue, my next time I'm going to come back to line 22. Okay, here is what happened? Oh, because it's doing the iterations, I shouldn't put it here. Okay, continue, and line 22 on the final grid. So let me go back a few times to see how the image is going to change. So now we are at an interval equal to 16. Let's go back to a more final grid. Okay, 128. Okay, so let's stop over here and look at what's the effect of the correction on the final grid. So let's first show our U0, and let me show U0 times 10. So we have this is the same U0 as we had before, right? Before we perform the coarser grid iterations. This has the very sharp features. Now, if I make another figure, if I do IM show of the coarser grid solutions, which is DU. This is my DU. Let me compare this, right? So my final grid solution is very sharp, but only it's bigger, but only contains the very sharp features, the high frequency contents. My coarse grid solution is actually a lot better, right? But it's smaller. Therefore, what I do is I perform this interpolation. So let's go here, and we have the DUF. Now let's look at IM show of what is DUF. This is DUF. If you compare this, this is my original U0. This is my DUF. So U0, DUF. You can see that DUF is blurred, right? Because it's interpolated from the coarser grid. While if you add this up to DU, let's do that. Let's step so that we have U1. We figure IM show of U1, which is the summation of U0 and DUF. Get a solution that is of course much better than U0, but it's also better than the interpolated coarse grid solution. So so this is interpolated coarse grid solution. This is the summation of these two. Coarse solution, summation, right? You can see like the solution has improved. It has its the sharp features on top of it. Okay, let's keep going through the code, and now we are at a even finer grid. So 1024. So that's at our finest grid, right? So we can see the same thing here. I'm gonna close it. I'm gonna show the U0. The U0 has the very sharp contents of this airplane, and DUF has almost the entire solution, but it's probably missing the most high frequency contents. And now if I step over, I have U1. So that's our funnel. That's our summation of the coarser grid solution and the smoothing I have performed in my finest grid. Okay, and continue. I'm done with one multigrid cycle, right? So I have stepped going down from the finest grid to the coarsest grid, and then back to the finest grid. So one iteration, I have solutions of all frequency added together, and that's still not fully converged because I performed only one cycle. And if you keep performing these multi-grid cycles, you're going to converge to the solution.